Okay, so this is the electrolysis of a molten substance. Electrolysis of molten, let's take lead bromide. So you've got to be careful when we do look at electrolysis. Sometimes you might be electrolyzing an aqueous solution, which means it's got water in it. Other times it could be just a molten substance, and the products will be different depending on which one it is. So let's just take something that is molten. So lead bromide is PbBr2. So it's going to be molten, so we're going to be it's going to be made into a liquid. Now what we're doing here is, when we carry out electrolysis, we look at the electrodes. We think about the positive and the negative charges. So say you've got a positive electrode and a negative electrode. Now when you take lead bromide, you will get two ions. So you'll get Pb2 plus and Br minus, but you'll get two lots of Br minus. But it doesn't really matter, because it just means the ratio is a 1:2 ratio. That really doesn't matter when it comes to electrolysis. The lead is going to be positively charged, the bromide ion is going to be negatively charged, which means that the Pb2 plus will obviously be attracted to the cathode, and the Br minus will be attracted to the anode. Okay, so there is no other ions. This is the reason why we need to be careful when we think about molten as opposed to a solution. The only two ions are the ions that come from the substance. So in this case it's lead bromide, so there is no other ions that will affect the electrolysis. So then we look at what's happening at the electrode. So obviously positive is attracted to the negative, negative attracted to the positive. So let's just look at the anode. So with the anode is the positively charged ion, positively charged electrode, and obviously the negative ion will go towards it. So you've got Br minus. When it reaches the electrode, it will it has electrons running through it, but Br2, what it will do is it will become Br2. So Br minus will become Br2. So you need to think about, how is Br minus becoming Br2. So first of all, you'll obviously need two lots of those Br minus ions, and then Br minus means it's got an extra electron, and because there's two Br minus, that means in total you'll have two extra electrons. So what the bromine, to make it bromine, you'll have to lose these two extra electrons, and you'll end up with the loss of two electrons, which is 2 Br2 plus 2E minus. So that's what's happening at the anode. At the cathode, you've obviously got the positive electrode going there, positive ion, Pb2 plus, and then it needs to become, or it becomes Pb, solid Pb. Now, if it is to become lead, it needs 2 plus, means it's lacking in 2 electrons, so it will need to gain 2 electrons, and it becomes Pb. Okay. Again, oxidation is the loss of electrons, reduction is the gain. So this is losing electrons, so this is oxidation. This is gaining electrons, which is reduction. This is happening at the anode, this is happening at the cathode. And there is no other ions involved. There is no competition between ions, because the only two ions are Pb2 plus and Br minus. Okay, and that's it.